Today we're going to look at a third form of a parabola, and this is known as vertex form. And the reason why it's called vertex form is it's really easy to graph. So we're going to go ahead and jump in. We already know standard form, we already know product form, and now we're going to learn a third form for our quadratic equation called vertex form. So let's go ahead and jump on over to our notes. So we are working on vertex, also known as graphing form. And we're going to be taking a look at this and seeing how it's different than the forms that we already know how to do. So we started looking at what we call standard form. There's an R in there. And standard form is y is equal to ax squared plus bx plus c. And what standard form gives us really well is it gives us the y-intercept just from looking at it. So just looking at it, we look at c and we know that that is going to be our intercept. And then we have product form. And what we do with a generic rectangle diamond problem is we turn a quadratic from standard form into product form. And product form is y is equal to x minus some number or plus and x minus a different number q. And then we use the zero product property to find the roots. So in this form, it's easy to find the y-intercept. And that, of course, is our c. And product form, it's easy to find the roots, which are the x-intercepts, by setting each of those equal to 0 using the zero product property. So today we're going to look at vertex form, and shockingly enough, it's easiest to find the vertex if something's in vertex form. So we're going to go ahead, vertex form. And vertex form looks like this. Y is equal to a parentheses x minus h squared plus k. Okay, so it looks all big and fancy, but we're going to go ahead and break that down. So the way that we would see this with an actual equation is y is equal to 2 times the quantity x minus 3 squared minus 8. Okay, now what we can do with this is a number of things. The first one that we can do is, of course, find the vertex. Find the vertex. And we know that our vertex is an ordered pair, x, y. Okay? And the way that we look and see that x is it is the opposite of h. So it's the opposite of h in this case. And our y is simply k, exactly as written. Okay, so for this particular problem here that we're looking at in purple, I look at the number inside the set of parentheses, and I see that that's a -3. So I'm going to do the opposite of -3, which is +3. And then I look at the number on the outside, and I write that down exactly as is, -8. So my vertex, very simply, is 3, -8. So we have to think of it as the opposite of the number inside and the number outside exactly as is. Okay, so that we could go ahead and plot that on our graph, the point 3, -8, and we know that that is either the lowest point or the highest point. Now, the second thing that we do after we find the vertex is we can go ahead and find the roots. So we're going to rearrange and we're going to basically solve for x and find those roots using the order of operation. So the first step in order to find the roots is set y equal to 0. Okay, so in this case, we're going to have 0 is equal to 2 times the quantity x minus 3 squared minus 8. And then the second step is we are going to solve for x. And this makes sense, once again, because we know that our roots, our zeros, our solutions, our x-intercepts are when y is 0. So we're going to go ahead and simply go through order of operations and solve for 0. Now, we're going to add 8 to both sides. Okay, and then what we have left is 8 is equal to 2 times the quantity x minus 3 squared. And then we're going to go ahead and divide by 2. And that gives us 4 is equal to x minus 3 squared. Once we've isolated that set of parentheses that's squared, we're going to do the opposite operation of squaring, which is the square root of both sides. Now, the thing about the square root of a number is I'm looking for a number times itself that's equal to the number underneath. So the one that everyone thinks of right away is 2, because 2 times 2 is 4. However, negative 2 is also a correct answer because negative 2 times negative 2 is positive 4. So when we take the square root of this number, we're going to go ahead and write a plus minus in front of it. And that's going to symbolize that we're going to do 2 items here. We're going to add 2 and we're going to subtract 2. Over here, the square root and the square undo each other. So all I have left is what's underneath the root, x minus 3. Now we're going to go ahead and we're going to add 3 to both sides. Okay, this leaves me x all by itself. However, I'm going to write this in 2 different ways, once with adding and once with subtracting. So I have 3, I'm going to do the top one, plus 2, and then I have 3, and I'm going to do the bottom one, minus 2. 3 plus 2 is one of my x's, and 3 minus 2 is my other x. 3 plus 2 is 5, so I'm going to have a root at 5, and 3 minus 2 is 1, so I'm going to have another root at 1. So now I have enough information to go ahead and graph. I have my handy dandy ruler. Make sure you're using your ruler. And we're just going to do a quick sketch of how to graph this from form. So we're going to go ahead and go to 5, negative 5, okay, and first we're going to go ahead and plot that vertex, which once again was the opposite of the number inside. The opposite of negative 3 is 3, and the exact number on the outside. So we're going to plot 3, negative 8, and then we're going to plot our roots. We have a root at 1 and a root at 5. And you know, if we add those together, 6 divided by 2, 3, that's another way to check that we have that correct vertex. Now, we don't have this same equation in standard form or product form, and so I don't have my y-intercept like I normally would for an extra point. So I'm now just going to make a smooth curve going up from each side. So this, ladies and gentlemen, is vertex form and how to take an equation in vertex form and graph it by finding the vertex, the opposite of what's inside your parentheses, and the outside exactly as is, and then find roots by setting it equal to 0 and using your order of operations to solve for x. Now, once again, be careful here. I want to remind you one more time, when you take the square root of both sides, you're always going to have a plus minus in front of it, and that's how it turns into the 2 roots. We're going to add that number, and we're going to subtract that number. Let's go ahead and get some practice in our Desmos activity.